from around the globe. It's theCUBE, with digital coverage of AWS reInvent 2020. Special coverage sponsored by AWS Worldwide Public Sector.
Welcome to theCUBE Virtual. This is our coverage of AWS reInvent 2020, specialized programming for worldwide public sector. I'm Lisa Martin. I've got a couple of guests here from Novetta. Please welcome Stephen Adelman, Principal Computer Scientist, and Kevin Heald, Vice President of Information Exploitation. Gentlemen, welcome to theCUBE.
Thank you.
Thank you for having us.
All right, guys, so Kevin, we're going to start with you. Give our audience an introduction to Novetta. What do you guys do? Who are you? How do you play in the public sector government space?
Great, yeah, thank you, Lisa. So Novetta is a technology services company focused on government solutions. So primarily national security solutions. So think customers such as DoD, the intelligence community, FBI, law enforcement, and things like that. About 1,300 employees worldwide, primarily, in our field, cleared resources that really focus on cloud-first solutions for our customers. So solving the tough mission challenges our customers have. So that could be in technology solutions such as data analytics, AI, ML, IoT, secure workloads, full spectrum cyber, COP, video processing, really anything that's a high-end technology solution is something we do for the government. It's a privilege to be a partner with AWS for some time now. In fact, I think the first reInvent we may have been to, Stephen, was 5 years ago?
2012 or 13.
Yeah, so we've been around for a while, really kind of enjoying it, and certainly sad that we're going to be missing an in-person reInvent this year, but looking forward to doing it virtually. So we are actually an advanced tier partner with AWS with a machine learning and government competency. And really kind of to pump the ML side of that, that was one of our first competencies with AWS, and led by a center of excellence that I have in my division that really focuses on machine learning and how we apply it for the mission. And so really we focus on protecting the nation and protecting our equities as a country.
And on behalf of the country, we thank you. Stephen, give me a little bit of information from a double-click perspective as computer scientists. What are some of the key challenges that Novetta helps its customers solve, and how do you do that with AWS?
Yeah, thank you. So really, as a company that is data first, so our initial love and still our kind of strongest competency is in applying solutions to large data sets. And as you can imagine, the bigger the data set, the more compute you need, the more resources you need, and the flexibility from those resources is truly important, which led us very early, especially in the government space and public sector space, to be an early adopter of cloud resources, because of the fact that, rather than standing up a 200 node cluster at many millions of dollars, we could spin up AWS resources, process a big data set, and then get the answers an analyst or an operator needed, and then spin down those resources when that kind of compute wasn't needed. And that has really kind of informed how we do our work as Novettans, that cloud infrastructure, and now pushing into the edge compute space, still kind of keeping those cloud best practices in play to get to access to more data. The two biggest, I think, revolutions that we've seen with regards to using data to inform business processes and missions has been that cloud resource that allows us to do so much with so less and so much more flexibly. And then the idea of cheap compute making it to the edge, and the ability to apply sensors to places where it would have been operationally or cost prohibitive to do that. And then ironically, those are two things that aren't necessarily data analytics or machine learning focused, but man, did they make it easier to collect that data and process that data and then get the answers back out. So that really has kind of shaped a lot of the way Novetta has grown as a company and how we serve our customers.
So Kevin, back over to you. One of the things that we've been talking about almost all year is just the acceleration in digital transformation and how much faster organizations, private sector, public sector need to innovate to stay relevant to stay competitive. Are you working with government customers to help them innovate so quickly?
We are very fortunate to have a set of customers that's focus is actually innovation. Its focus is IRAD. And we can't do the cool things we do without those customer relationships that really encourage us to try new things out and, quite frankly, fail quickly when we need to. And so by establishing that relationship, what we've been able to do is to blend agile development, agile acquisition with government requirements process, right? If the typical stereotype of government work is it's this very stovepiped, hardcore acquisition process, right? And so we've been fortunate to instead try quick win kind of projects. And so one of the biggest things we do is partner with our government customers and try to find a difficult challenge to solve over a 6 to 12 month time, right? So instead of making this long 4 or 5 year acquisition cycle, it's like, show me, right? How can we solve this problem? And then we partner with the mission partner, show success in 6 months, show that we can do it with a smaller pot of money. And then as we're able to actually make that happen, it expands into something bigger, broader. And then we kind of bring together a coalition of the willing, if you will, in the government and saying, okay, are there other stakeholders that care about this problem? Bring them on, bring their problems and bring them together. And, we can't do that with some of the passionate people we have. Like Stephen's a perfect example. When we talk about Picard and the projects we're doing here, Stephen's passion for this technology partnered with our customers having these challenges and trying to enhance what they're doing is a powerful combination. And then the last thing that we're able to do as a company is we actually spend a decent amount of our own dollars on IRAD, so R&D that we fund ourselves. And so while finding those problems and spending government dollars to doing that, we also have spent our own dollars on machine learning, IoT, sensor, next gen 5G, and things like that, and how those can partner together to go back to the government.
Yeah, Kevin.
Go ahead, Stephen.
Oh yeah. So I would even say, there's a conventional wisdom that government is slow in plotting and a little bit behind commercial best practices. But there are pockets and growing pockets across the government where they're really kind of jumping ahead of a lot of processes and getting in front of this curve, and actually are quite innovative. And because they kind of started off from behind, they can jump over a lot of kind of middle ground legacy technologies, and they're really innovating. As Kevin said, with the Picard platform, we're partnering with PEO Digital in the Air Force and SAF CDM and Air Force Security Forces as that kind of trifecta of stakeholders who all want to kind of saw a mission problem and wanted to move forward quickly and leave the legacy behind and really take a quantum leap forward. And if anything, they're driving us to innovate more, to introduce more of those kind of modern practices. And Novetta as a company loves to find those spots in the government sector where we've got those great partners who love what we're doing, and it's this great feedback loop where we can solve hard technical problems, but then see them deployed to some really important and really cool and impactful missions. And we tend to recruit that kind of nexus of people who want to both solve a really difficult problem, but want to see it executed in a really impactful way as well. And that really creates a great bond for us. And I'm really excited to say that a lot of the government is really taking a move forward in this realm. And I think it's just good for our country and good for the missions that they support.
Absolutely. And it's also surprising because, as you both said, there is this expectation that government processes are lengthy, laborious, not able to be turned around quickly. But as Kevin, you just said, helping customers, government agencies get impact within 6 to 12 months versus 4 to 5 years. So you talked about Picard, interesting name. Kevin, tell me a little bit more about that technology and what it is that you guys deliver that's unique.
Well, I honestly, it's probably best to start with Stephen. I can give you the high level. This is Stephen's vision. I have to give him credit for that. And I will say we have lots of fun acronyms. So it is an acronym, right, Stephen? Doesn't it actually stand for something?
It stands for Platform for Integrated C3 and Responsive for Defense.
Okay, impressive.
The Star Trek theme is a leg up from the last set of programs I had, which were named after My Little Ponies. So,
Oh, wow. That's a definite step in a different direction. I
right.
like it.
Part of the great thing about working in the government is you get to name things cool things. So, but to get to your question, so Picard really sprung out of this idea that I had a few years ago that that the world, but for our space, the Department of Defense and the federal government was going to see a massive influx of the desire to consume sensors from areas of responsibility, from installations, and frankly, from battlefields. But they were going to have to do it in a way that presented some real challenges that you couldn't just kind of throw compute at it or throw traditional IT processes at it. You know, we have legacy sensors that are 40 years old sitting on installations, you know, old programmable logical controllers or facilities control systems that were written in COBOL in the 70s, right? And are not even IP based, most of them. And then on the other end of the spectrum, you have 7-figure sensors that are, you know, throwing out megabits of second of data that are mounted to the back of Jeeps, right? That are bouncing through the desert today, but will be bouncing through the jungle tomorrow. And you have to find all of those and combine all of those together, and kind of create a cohesive data set for, you know, the mission, for you know, what we call a user-defined common operating picture, for a person to kind of combine all of those different resources and make it work for them. And so we found a great partner with security forces. They realized that they wanted to make a quantum leap forward. They had this idea that the next defender, so they're like a military police outfit, that the next defender was going to be a data-driven defender, and they were going to have to win the information war as much as they had to kind of dominate physical space. And they immediately got what we were trying to achieve. And it was just this great synergy. And then we've piled on some other elements, and we're really moving that platform forward to kind of take every little bit of information we can get from the areas of responsibility and get it into a, you know, your modern data lake where they can extract information from all that data.
Kevin, as the VP of Information Exploitation, that's a very interesting title. How are you helping government organizations to win the war on information, leverage that information to make big impact fast?
Yeah, I mean, I think a lot of it is that we try to break down the barriers between systems and data so that we can actually enable that data to fuse together to find and get insights into it. You know, as ML and AI have become trendy topics, you know, they're very data hungry operations. And I think what Stephen has done with Picard and his team is really, we want to be able to make those sensors seamless from a plug and play perspective, that I can plug in a new sensor. It's a standards-based interface that sends that data back so that we can then take it back to the user-defined operation picture and make some decisions based off of that data. You know, what's more is that data could even be fused with more than the data that Stephen's collecting off those sensors. It could be commercial data, other government data. And I think as Stephen said earlier, you have to get it back. And as long as you've gotten it back and you're able to share it with some of our mission partners, then you can do amazing things with it. And, you know, Stephen, I know you have some pretty cool ideas on what we're going to do on the edge, right? How do we do some of this work at the edge where a sensor doesn't allow us to pull all that data back?
Yeah, and to follow on to what you were kind of referring to with regards to handling heterogeneous data from different sensors, one of the main things that our government customers and we have seen is that there are a lot of historically, there are a lot of vertical solutions where, you know, the sensor, the platform, and then the data lake are kind of all part of this proprietary stack. And we quickly realized that that just doesn't work. And so one of the major thrusts of that Picard platform was to make sure that we had a platform by which we could consume data through adapters from essentially any sensor speaking any protocol with any style data object, whether that was an industry standard or a proprietary protocol. We can quickly ingest it and bring it into our data lake. And then to pile on to what Kevin was talking about with compute, right? So you have like almost like a Maslow's hierarchy of needs when it comes to cyber data or to this IoT data or kind of unified data. You want to turn it into basic information, alerts, alarms. Then you want to do reporting on it or analytics or some higher level workflow function. And then finally, you probably want to perform some analytics or some trending or some anomaly detection on it. And that gets more computationally intensive each step of the way. And so you've got to build a platform that allows you to both take some of that high level compute down to the edge, but also then bring some of that data up into the clouds where you can do that processing. And you have to have kind of fungibility between that. And so that Picard platform allows you to kind of bring GPUs and high processing units down to the edge and make that work. But then also, and then as maybe even a first pass sieve to rule out some of the most, some of the boring data. In the video analytics platform, we call it blue sky and blue ocean, right? So you're recording lots of video that's not that interesting. How do you filter that out so you're only sending the information, the interesting video up, so you're not wasting bandwidth on stuff that just doesn't matter? And so it's a lot of kind of tuning these knobs and having a flexible enough platform that you can bring compute down when you need it, and you can bring data up to compute on big cloud while you need it, and just kind of finding a way to tune that. That really does. I mean, that's a lot of words about how you do that, but what that comes to is flexible hardware and being able to apply those DevOps and CI/CD platform characteristics to that edge hardware, and having a unified platform that allows you to kind of orchestrate your applications and your services all the way up and down your stack from microcontrollers to a big cloud instantiation.
You make it sound so easy, Stephen. Kevin, let's wrap it up with you. In terms of like making impacts and going forward, we know the edge has exploded even more during this very interesting year, and that's going to be something that's probably going to stay as a permanent impact or effect. What are some of the things that we can expect in 2021 in terms of how you're able to help government organizations capitalize on that, find things faster, make impact faster?
Yeah, I mean, I think the cool thing we're seeing is that there's a lot more commoditization of sensors. There's a lot more sensor information. And so let's use LiDAR as an example. Things are getting cheaper. And so we can all of a sudden do more and more things at the edge than we ever would have expected, right? When, Stephen's team is integrating camera data and fence data from 40 years ago, it's just staying on off. It's not doing anything fancy. But now Stephen, I can't remember what the metric you gave me before was, but the cost of LiDAR has dropped so significantly that we can now then deploy that. We can actually roll it out there and not be locked into a proprietary system. So I see that being very powerful. Also, I can see where you start having sensors interact with each other, right? So one sensor finds one thing, and then a good example that we've started to experiment with, and I think, Steve, you could touch on it, is using triggering a sensor triggers a drone to actually investigate what's going on, and then therefore can bring video back and then automatically can investigate instead of having to deploy a defender to actually see what happened at that endpoint, Stephen. I don't know if there's some more detail you can provide there.
Yeah, no, so exactly that, Kevin. So the power of the sensor is something old that gives you very uninteresting data, like a 1 or a 0 or an on or an off, can detect something very specific and then do something kind of high speed, like task a drone to give you a visual assessment, and then run object detection or facial recognition on, do object detection to find a person and do facial recognition on that person to find out if that's a patrol walking through a field or a bad guy trying to invade your space. And so it's really the confluence and the gestalt of all of these sensors and the analytics working together that really creates the power from very simple delivery. I think there's this, this idea that, 100 bytes of data is not that important, but when you put 1 million sensors giving you 100 bytes of data, you can truly find something extremely powerful. And then when you kind of, and you make those interactions sing, it's amazing to us, the productivity that we can produce and the kind of fidelity of response that we can give to actors in this space, whether that's a defender trying to defend a base or a maintenance person trying to proactively replace the fan or clean the fan on an HVAC system. So there isn't a fire at a base interestingly enough, one of the things that we've been able to achieve is we've taken maintenance data for helicopter engines, and we've been able to proactively say, hey, you need to take care of this part of the helicopter engine, and it saves money, it saves downtimes, it keeps the birds in the air, and it's a relatively simple algorithm that we were able to achieve, and we were able to do that with the maintenance people, bring them along in this endeavor and create analytics that they understood and could trust. And so I think that's really the power of this space.
Tremendous power. I wish we had more time to dig into it. Guys, thank you so much for sharing not just your insights, what Novetta is doing, but your passion for what you're doing and how you're making such an impact. Your passion is definitely palpable. Stephen, Kevin, thank you for joining me today.
Cool. Thank you.
For my guests, I'm Lisa Martin. You're watching theCUBE Virtual.